Hey everyone, I'm Gwen Shapira and I'm so excited to be here with you for Druid Summit. If you don't know me, my background for the last 20 years is in data architectures, and for the last 8-ish years I've been working on Apache Kafka building real-time data architectures both as a product manager and as an engineering leader at Confluent. And then I left Confluent and I started a company with the goal of helping other companies build amazing software as a service. So today I'm going to combine my two favorite things and talk about real-time data analytics in modern software as a service. So we're going to start, as I said, I used to be a PM, I'm still a PM, I'm PM at heart, and I usually start thinking about problems and solutions by thinking about the persona, the people who have problems and need them solved. So I'm going to spend a little bit of time talking about who are the people who need real-time analytics. Then I'll switch over to software as a service use cases, and I'll finish by different architectures that I've seen, some of which solve those use cases and some of those look like they may solve them but are actually a trap. So let's get started. Who are the people who need real-time analytics? Well, before we get into that, let's for 1 second define what is real-time analytics, because a lot of people have different ideas. When I think about real-time analytics, I'm thinking first of all about fresh data that was generated seconds or milliseconds ago, not data from yesterday. I'm thinking about analytical tools and querying tools that are very responsive, that I run a query and I get back a result in milliseconds or seconds, not hours. I'm thinking about different abilities to slice and dice the data, like it's not a key value store. I can actually run different queries and aggregate and filter and all those things. And hopefully the data is accurate, because real-time analytics very often ties to alerting and automated actions that happen as a result of the data. And the last thing anyone wants is to take automated action based on the wrong data. So accuracy is extremely important as well. So who needs all those things? I'll tell you who does not need all those things. There are people in your business that keep asking you for real-time data, but they don't actually need it. BI analysts and business units usually don't have the need for this split-second, real-time, changes all the time, extremely fresh data and decision-making. Your business strategy changes annually, maybe quarterly. It is not something that changes second to second. So usually, even if they ask you for real-time data and you give them to them, the tiniest trade-off will cause them to say, oh, I'll actually go back to my old ways. Oh, you don't support Tableau, let me just go back to my old thing. And the reason is that they did not really need it in the first place. They just wanted it. That's not completely true. There are few business units that do need real-time data, like the guys who are optimizing your social media and advertisements. But generally speaking, real-time data is for driving real-time decisions, and very few people in your business units and business analytics really need that. So who does need that? Well, your customers need it. Why do your customers need it? Well, if you are anything like the 100 SaaS companies that I talked to in the last year, a lot of them are building collaborative software. So their customers need to collaborate. Collaboration is something that happens in real time. And they want to do things and be sure that other people in their team is seeing it, can react to it. They need to react fast to things that change. Very often, the reason you're here is that this is your application, this is what you do. Allow people to understand the world fast and react to it. And a lot of time they are capable of doing automation. They will connect the data and analytics to alerts, to automated emails, changes to ad spend, all those things will exist for them. So they have the ability to use this real-time data to do things that are actually useful. And the last reason that your customers need real-time data is that having this transparency in real time helps them trust your product. So let's say that you have a usage-based billing, and usage-based billing is based on data. So someone goes in and changes something in the application and uses something, and then they go to the billing tab and they want to see, did it change anything in my spend? Did it change anything in my projection? Did you even see that I did it? And if what they see in your product does not match what they believe they just did and what they believe should have just happened, that you will lose trust. And okay, sometimes it's delayed a bit, so let's wait a minute, wait 5 minutes. After half an hour, it's probably a support call, or worse, they'll just leave and not come back because clearly they cannot trust you to bill them on the right numbers. So trust is really important. Your customers want to trust you, but you need to provide them with ways to trust but verify. And the data is a way to verify. And as my personal hero, Edward Deming, said, in God we trust, everyone else, especially vendors, have to bring data and earn our trust. So with that in mind, we now know what we're building and who needs it and why they need it. Let's talk a bit about what is modern SaaS. And in order to explain what is modern SaaS, it will be good to talk about what is non-modern SaaS, what SaaS used to be and how it's different today. So I'm going to take us back all the way to the first SaaS ever, which surprisingly happened in 1960. If you think about the machines in 1960, you did not have a personal computer back then. There were those big machines, they were timeshare, so you'd book your time on the computer and you'll do your job. The software ran on this big computer, you just had a nice terminal. All software in 1960 was software as a service. There was absolutely nothing else, which is kind of amazing that how fast we forgot about that time. Now, between 1960 and 1996, two things happened at the same time. First, personal computers showed up and kept getting better really fast. Moore's law and everything, the machine we have now is much, much better. Your phone is much better than the computers that sent people to the moon. It's unbelievable. So obviously, as computers are getting better, you can do more and more things on your personal computer that before you had no way of doing. Video editing and photoshopping, data analytics, you can do so much on your local machine. So this kept getting better. On the other hand, the internet kept getting better. Suddenly there is internet in every home. Later we had broadband. So one force is pulling away from software as a service because the local machine is so good. The other force is pulling towards that because the internet is getting better and better. 1996, the first time that people looked around and said, oh, the internet is so much better, maybe we can run software for other people. Maybe this is a viable business model. And if you look at the companies that tried to do SaaS, back then it was called ASPs. In 1996, A, pretty much all failed, and B, what they sold, their aspirations, were exactly the same as today. You don't have to install your software, we will manage it for you, it's going to be very easy, it will be fast, we have all those buy computers in the cloud for you. All those promises, uptime, all those things were exactly the same. Problem is, technology wasn't there, so they couldn't deliver. 96. Most homes had a modem that had like 8K bandwidth, more or less. Broadband was definitely not common. The ability to scale things up and down in the data center was not there. There was no cloud, there was no virtualization, there was really nothing. So the dream was correct, but we had no ability to act on it. By 1999, 3 years later, this has changed and the first viable SaaS companies showed up. And Salesforce was founded in 1999 and said, hey, you no longer have to install Siebel, we'll do it for you. the first hosted monitoring as a service, what is now Datadog, showed up as ActiveWatch back then. We are going to run a bunch of agents and we will monitor the website for you. And it's 1999, so every business has a website. They all need to monitor it. Much easier for businesses to basically buy a timeshare on a distributed agent and have a lot of monitoring from everywhere for the website, which is public anyway. So this was the inflection point. And from there, everything started getting better. By 2006, AWS existed, which obviously changed the ability for small companies to really start small and scale their SaaS business as one should. Google Apps, maybe the original collaboration software where you open a document and multiple people can edit it together, showed up in 2006. And GitHub, which is another amazing collaboration software, also showed up in 2006, allowing developers to collaborate on code. Really good stuff. Fast forward another 5 years, and things are getting much better because they have richer data in real time because our networks are getting better. This is when you see Slack, you see Zoom, you see Figma, you see Datadog, much more data rich than we had before and much more real-time collaborative. And 5 years later, we have things like MongoDB Atlas, Confluent Cloud. Those are now selling you databases as a service, essentially, or real-time streams, real-time analytics as a service. And those are very data rich. And it's good to see that AWS is not really database as a service or even infrastructure as software as a service, because you have to worry about very low level things. Definitely back when it started, you had to pick disks, you had to pick machines. The new generation of those infrastructure services give a user experience where they abstract a lot of the details. They are very serverless. You think about capacity in a very high level. They are usage-based billing, meaning they need a lot more data to give this experience. And we'll talk about that in a second. So at a very high level, the more you go forward, the more things are real-time, the more things are collaborative, the more they take advantage of the capabilities of a modern internet and a modern data center. And it's important to know this trend because software as a service is not taken up and run it on someone else's computer. The ability for you to provide a good user experience is much different. You can crunch more data behind the scenes. You can have very complex architectures. You can enable all those collaboration and sharing and sending things. You know that Google Apps is a real modern software service because you no longer send emails with attachments that are called important document revision number 503. So you really are building towards that. On the other hand, the customer expectations are pretty much what they had on their own machine. It has to be immediately responsive, do exactly what I want, just like it's running just for me. It cannot slow down just because someone else is using it, but it has to be even better. It's not allowed to crash. It's not allowed to do random stuff. Like, it's okay if stuff on my computer crashes, I'm like, oh, fuck it, Microsoft, you know what I mean. If your software as a service crashes, well, I don't think it ever happens. The software as a service even crash. I think our availability is, 99999 and so on. Extremely rare. People are shocked. On the other hand, the moment something doesn't work, they assume it's the cloud provider. It's never their fault because they're not running anything. They're just using your UIs or calling your APIs. How can it possibly be their fault? So you really need to be mindful of those high expectations and the nice modern SaaS experience. And the table stakes for this is, first of all, consistent low latency, both for enabling collaboration and trusting the data, and because people really expect that it will behave software as a service should behave as if it's on their local machine. They don't expect any latency at all. There's zero tolerance. The other thing is that security and compliance are table stakes. People want to use software as a service. I understand it's more convenient, it's better, it has all those benefits, but there could be people in their own organization saying, no, you cannot use these things that you want to use because it didn't pass these certifications, they don't jump through those hoops, etc. I've been in tons of those conversations. It's always heartbreaking to see that I'm missing a checkbox and therefore someone who wants to use my product cannot. Always frustrating because when I ask the security person, well, you use S3. S3 doesn't do it. Why do you need me to do it? And they'll look at me like I'm an idiot and say, well, S3 is AWS. Are you AWS? No, you're not. So there's trust that you give really large famous vendors that earn the trust, and there is you who still need to earn the trust. Going back to what I said, the best way to earn trust is to give data, and real-time data allows people to verify your data in real time because they do something and immediately they watch the data. If it matches their expectations, they're good. So super important to be aware of that. And now that we know how high the bar is, let's raise it even higher and talk about the user experience expectations and how data play in real time plays into that. So the first thing that goes above table stakes that is still considered a competitive advantage is the ability to collaborate in real time. We started in 1999 as someone else is running the application, and then it became it's running the application for a lot of people at scale. I don't have to worry about capacity. I can invite other people who work with me to work on the same things that I do. And then after that, we want to start collaborating and actually see each other activities through the app. And the example I have here is from Datadog, where they provide essentially incident notebook. So if imagine incident in your data center, what do you really need? First, you absolutely have to have fresh data. It's not optional. It's not something you can trade off. You cannot troubleshoot an incident without very, very fresh data. Second of all, you need to be able to slice, dice all the data and have it happen fast. The worst thing can happen is that your data center is down and you're waiting for the query to finish so you can figure out what happens. And the third thing is that a lot of different people with different roles need to be able to look at all the data, play with it together, and communicate. Oh, I think this means that. I think this means the other thing. Let's pull up this next report to actually verify what's going on. This is almost like when I said that sometimes real-time analytics is nice to have and sometimes you actually need it. Operations and especially incidents is exactly when you actually need real-time data and you actually need the collaboration and you need all of it almost perfectly right now. The other side of not just in addition to collaborating both on data or just on documents, there is an aspect of modern SaaS that I want to call a data-driven experience. What do I mean? I mean that the user experience itself, because of data that the vendor has, they can personalize your experience. They can offer you more information inside the app to make your experience better. They can have better ways of billing you that make you more likely to buy the product. It aligns how you use the product with how they make money, which is always great. And it allows them to do some features that without really good capabilities around real-time data, you couldn't. So let me go over a few examples so you will understand what I'm talking about. The first one is GitHub. This is my landing page. I hope this girl looks familiar. And you can look at how data-driven my landing page is. First of all, up above is my popular repositories. You couldn't know what repositories that I have are popular without having a lot of data about what people are actually doing. And then you have my activities, nicely charted. Look at how much data is shown in such a small space over here, and they obviously allow you to slice and dice it in real time. The achievements are driven by data, the followers, like everything here is data, and this is just the landing page. If I click on repositories, I see traffic, I see merges, I see the top contributor, Every single page on this website is personalized and data-driven, which is absolutely amazing. Let's take another example. Maybe my favorite database as a service or clusters as a service, Confluent Cloud, offering Kafka as a service, KSQL as a service, all those things. They have a lot of data because they're running your Kafka clusters for you. So they know your throughput, they know your utilization, connections, pretty much everything that the cluster is going through, they know what it is. And they need to give you this data, because sometimes you're like, hey, what's up with my cluster? Is it up? Is it down? I'm seeing something weird. So you need to go and take a look at the data. And by the way, a good example of trust. If the data that you see in the website says everything is green, but you're seeing dropped packets everywhere in your clients, you lose trust. So this is a case where if the data is accurate, real time, then you gain a lot of trust. If it's not, you can lose it. But it gets even better because just watching data is not enough. Sometimes you need to make decisions. And one example of those decisions is how big should my cluster be? So Confluent Cloud is very elastic, but it's still not 100% auto-scalable. So, or maybe now it is, but last time I looked, it wasn't. So you select your size of the cluster and then you can change it. So if you, at any time, if you want more, you just drag the little button and you get more. And in order for you to decide on the size, they show you what you're using now and how it relates to the change you're going to do. And this is obviously very data-driven, and they hint at, hey, maybe I'm making a mistake. I'm using a lot of the cluster and I'm trying to shrink it here. It's not going to be a very good idea. And in some cases, what the cluster is doing right now is important, but not enough. Because right now the cluster load is 23%. Does it mean that I can shrink it? I don't know, maybe every day at midnight it spikes up to 100% and it will be a catastrophe if I shrink it. So they also let you click and see the historical data. So note at how you are there to make a decision, how big should my cluster be next, and they show you all the data in order to make this decision correctly. So really good user experience, and you cannot do this kind of user experience without accurate data available in the right dimensions in real time. And since I used to work there, I can share, and you probably already know, this is all driven by Confluent's extremely large Druid cluster that is running the show there. So all those metrics, everything in real time from Druid. So this is pretty cool. Oh, and one more thing, Confluent also does usage-based billing. So as you change the size of the cluster, they also tell you how much it's going to cost you. Datadog. Now, Datadog has tons of data all over the place. I'm going to focus on two things that I feel are going slightly above and beyond of what I would expect of a normal monitoring system just doing its job, because we're here about raising the bar on what you do with data. So the first one is usage-based billing. You can see that they basically, in the billings page, they have a usage tab and they show you charts of what are you using. So you can kind of anticipate your bill, and you're also going to map it to what you think you're doing. It says here that I am using database hours. Database host. Am I actually using database host? I do. If I didn't, this would not be a good experience, but I do, and therefore it is a good experience. They are 100% accurate in my usage, and therefore when I get the bill, I do not anticipate surprises. The other part is that we talked about data being collaborative. One of the biggest ways to collaborate is by posting stuff on Slack channels. We all do that all the time. Datadog allows you to copy a link of any report, and when you paste the link in Slack, it shows you a picture of the report at the times that you copied the link. And you can even add annotations and do cool stuff. And this is obviously makes collaboration much easier. Even if I'm on my phone, I cannot really open Datadog, I lost my login. At least I know what the person, the next message will be, hey, I'm seeing CPU at that level, is it a bit high? And this gives me the context to respond to that message and say, oh no, it looks fine for me, without jumping through hoops. So sometimes collaboration is very small things. It's more about what it does for the users and how hard it is for an engineer to build it. And the last example, this is what I think is almost the perfect SaaS. It's Untapped. They started many years ago as a social network for people to share what beers are they drinking, how much they like them, what pubs they're drinking it in, and even write a small review of the beer. This was, I think, moderately successful, not as big as Twitter, but I know a bunch of people who use it. But over the years of running this social network, they collected the world's biggest database of which beers are popular in what places in the world, what are the keywords that are used to describe them, what is their average rating, which pub serves what. They have this amazing database that is basically, they got it for free by just having people talk about their beer habits over an application. They took this gigantic database and turned around and started selling it to pub owners. So they say, hey, just tell us what beers you're serving this week. We will auto-generate a menu. We will print it for you. We'll put it on a big screen for you. Not only do they show you, auto-generate the beers and the descriptions and even the rating, they also show you in real time who are the people who are currently drinking it. And so I can take a look and say, oh, I see a bunch of people are drinking Foothills Hopinam IPA. I'm going to try that. So it's actually very data-driven, very real-time, very interactive. You don't expect to see a beer here that ran out because they have the real-time data. Even better, they show you in real time what beers people are drinking in other pubs next door. So you can say, oh, it looks like everyone is drinking Tropical Lightning in my area. Maybe I should order it next week. It looks like it's popular. Decision making in real time, both for the pub customer and the pub owner. And this is just a fraction of what they do. They help you price it. They help you advertise it. It's so amazing what you can do when you have a lot of data. Like absolutely a moat for a business. So super impressive. And again, none of it would work without good ways to slice and dice data in real time. So how do we do it? What are good and bad architectures? Option number one, and pretty much everyone starts there. Let's say that you already have a production software as a service and people say, hey, we need a real-time chart in our application. You're an application developer. What's the thing you do? You ask them, okay, what should the chart show? And they say, oh, it should show in 5-minute interval the number of updates to tickets. And you're like, okay, select count star from tickets where group by timestamp and ticket or whatever. So you run this query and you get data and you kind of you go to the UI engineer, you draw a nice chart. Perfect. There is a flaw in this plan. Your OLTP database is not supposed to analyze data. You have very fast queries, usually using indexes. They're supposed to, in milliseconds, just pick up a row or two from your database. Your select star group by, it's scanning possibly a gigantic table. And it has to scan all of it, and then it has to do calculation. You're going to use all the CPU. Everyone who actually needs something in milliseconds, to open a ticket, it's going to be slow. Remember, you're not allowed to be slower than their own computer, so they're going to get upset. It will work for the first months, but the moment you push it to production, start writing the next version because this is catastrophe waiting to happen. Now, okay, it was a catastrophe. So you figure out the right thing to do, right? You have ETL and you push all your data to data warehouse, you munch, crunch, the data warehouse was meant to munch and crunch it, and then you just direct your query to the data warehouse. Are we good to go? No, you're not good to go. Why? Because the data warehouse was not built for real-time queries. It was built for very large, massively parallel queries, the ones that take every single processor and run for maybe several hours. You are going to have bad performance. In addition, usually the people who own the data warehouse are not your engineers. They're the data engineering teams that report to the business unit. They maybe don't even have CI/CD. They may not care if it goes down after 5 p.m. because the business unit already went home. They care much more that when a salesperson tells them to jump, they ask how high and immediately put it in. So you really cannot create something that is fast and reliable on this infrastructure. So what do? We realize this fundamental truth. I'm quoting my co-founder. A database is optimized for a use case. You cannot have a database that does everything at the same time. This is why we think about personas and what they're trying to achieve, and we build architectures for that. Every database has its use case, but you can combine them into a data platform that takes the strengths of each database and serves your needs. So let's look at data platforms. The first one that I see a lot of is what we sometimes call reverse ETL. If ETL is pushing data from your real-time system to a data warehouse, this is reverse. From the data warehouse to a fast system, and then from the fast system to your application. Very popular by different variations. I see a lot of it. Nothing wrong with doing this, but remember that the big data lakehouse does usually stuff takes time to run there, at the very least minutes, sometimes more. So it introduces latency, your data will be less fresh. And usually you push results after processing, which means that your slicing and dicing capabilities are a bit limited. Nothing wrong, but we can do better. How can we do better? Well, we take a database that was actually built for what we're trying to do, rather than continue trying to repurpose stuff that happens to be lying around the house. So the architecture that you actually want is a data platform architecture, meaning that you actually take all those best databases, the analytics DB that can do those fast slicing and dicing on data, and your relational database that lets you just show a single ticket at the right time when you need it. And you start layering it with, first of all, a secure access layer. The last thing you want is that someone is not allowed to know that the cluster exists when it's in the relational database, but when they look at the metrics, they see all the data about that cluster. This is a serious incident. You absolutely have to have the security and access rules apply across the board. Above that, you put a bunch of microservices. And this is nothing new. You already have a bunch of microservices. You probably have a lot more than one relational database as well, because every microservice has their own relational database. So you basically kind of just layer those things out. Your SaaS application talks via APIs or different ways of querying with your services. Your services decide that they need to get you your data from the relational database, from the analytics database. So, and this gives you this secure and fast architecture with actually not a lot of changes over what you would normally do. One thing to note is that the pipelines into the data analytics, it kind of looks like it may be very similar to the one in the data warehouse ETL kind of scenario, reverse ETL kind of scenario. It is not similar. This is a fairly dumb pipeline. It is not ETL, especially it does not have a lot of T in it. You're not trying to join, merge, pre-aggregate and all those things. This is why you have an analytics DB, so you can dump tons of data and let your customers crunch it in real time rather than delay the arrival of data because you wanted to pre-crunch it. This is literally the whole point, so don't miss out on this point. You don't usually push completely raw events. You kind of do some light processing, standardize the units, remove people's credit cards and social security, all the stuff that you know you have to do, but do it fast. Make sure that the thing that does it is extremely effective. And you kind of see all those processors that, use WASM and compile to machine and are incredibly, incredibly fast. So go with fast and simple pipelines to Analytics DB and let your customers' experience drive from, take advantage of the fact that you have an incredibly powerful real-time analytics database in your stack. So, to recap, your customers really need real-time data, not the business unit that refuses to stop using Tableau. I'm talking about your actual customers. They need it for collaboration and for actually doing their job by reacting fast to things that are happening in the world. They collaborate and they need data to collaborate. They also need data in order to trust you, their vendor. In order to deliver this real-time trustworthy data in real time that people can actually use in all those different ways, you need a production capable data platform, which is different than the business analytics data platform. So you need to design it for production with all the security, all the change management, everything, to make sure that it's extremely reliable, extremely fast, and ready to be customer facing. So you have Druid, and now you know what to do. So I hope I inspired all of you to perhaps build better software as a service, perhaps build better applications that maybe you didn't consider the possibilities before. If you did, I'm looking forward to hear from you. Hey Gwen, I listened to your talk and now I'm going to add this to my application. Now I'm going to do this to my architecture. It will be extremely exciting to me after a lot of time seeing what can be done for first my company and then for the 100 SaaS companies I talked to recently. I'm looking to inspire you and I'm looking to get inspired in return. Thank you so much for being here.